go. All right, so warm up 4.4. Log base 6 of 1 over the cube root of 36. The log is an exponent, right? The log is an exponent. So here's what I'm going to do. The log is an exponent. I'll put a box there. And what is the exponent in this case? Negative 1 over 3. I like the negative over 3 part. That's 2/3 of the answer. Okay, let's think about why it's negative. It's negative because powers of 6 get bigger, and I need it to be 1 over bigger. So to flip it, I need a negative exponent. The 3 in the denominator of the exponent or the log is because it's the cube root. All I got to do is fix the numerator. 36 is what power of 6? 2. Peace sign. So there you go. It's negative 2/3. So if you could do that in your head at this point, that's fantastic, right? But you could still set it equal to x. You could still convert it to exponential, doing the around the world trick, and then you can work on the right side separately, writing it as a power of 6, okay? But hopefully you have enough experience with logs that you're not afraid of them, and you know it's just an exponent, right? So when we agreed to talk about numbers in base 6, I can refer to this small number by its exponent, negative 2/3, okay? Right, Brady?
Yes.
No, no, no. You're not going to hold up your math as if that's what you were looking at, because I got there fast enough and I peered over the top. Good thing you're good for it. That's life, right? Learning how to switch back to what you're supposed to be doing real quick, right? It's humorous, right? It happens in class. I'm reading a comic, oh crap, here's the teacher. No, I'm doing math, right? But then you get in the workforce sometimes, and then you're like bored all day, and you're sitting at your computer, right? And then you're doing whatever you want, and then the manager comes by and goes, oh crap, no, really, I'm doing a spreadsheet, you know, but really you're on Amazon or eBay or TikTok or what? Cool math games. Cool math. Yes. Yes. Okay. It's okay. It's okay. It's okay. If you were failing, Brady, it would be a problem. But you know what? You're a good student. You have a high grade in this class. You can multitask. That's fine. I wasn't trying to catch you being bad. I was kind of curious what the comic strip was about. That's all. I like to be in on the jokes. I like to be in on everything. I want to know. I'm a curious fella. One piece? It's a one-piece comic strip? Like a one-piece suit? Like a onesie? Like a unitard?
No, it's a like Japanese comic book called One Piece. No, like one number. Yes.
Okay, I got to look this up.
That's the right spell.
Yeah. Okay. Japanese One Piece.
Yes.
Okay.
Exactly.
Okay. Got it. Thanks.
It's O-N-E space P-I-E-C-E.
So how many
One
pieces about
Piece.
this high?
Oh, okay. Okay. You lost me.
I'd say
Properties of logs. Properties of logs. Okay. Properties of logs. Let's just get the joke out. What's one important property of logs? They make good firewood. Yeah. They build good houses, right? Yeah.
there's a whole toy set named after them with Lincoln.
Yeah, Lincoln logs. Right.
We're making
So,
Lincoln logs?
Now that we know the property of wooden logs, the property of logarithms, mathematical logs, there's 3 of them, and they're super important. Remember that logs, as I've been saying, we refer only to the exponent on an agreed upon base. So logs, let's write this down. Logs make molehills out of mountains, right? Not really good if you're into mountain climbing, right? Because you want the mountain to be big. You want it to be almost insurmountable so that you can try to overcome it. But if you're just a casual person that's on the road, you're like, oh crap, there's a mountain in front of us. If only that were a molehill or two that we could just step over instead of arduously climbing and risking our lives in the death zone, right? Above 8,000 meters. So that's what logs do, okay? Here's the first property. I'm going to go to the right side. Property number 1. And this works for logs of any base, by the way, any base, but I'm going to choose base E for demonstration purposes, okay? So the natural log of A times B, where A and B are pretty much anything, numbers or variables. The natural log of A times B is the natural log of A plus the natural log of B. So the log of a product is the sum of the logs. Isn't that poetic? The log of a product is the sum of the logs. Now, what are you going to have to do? You're going to have to realize that if you have the log of any base of a product of 2 or more things multiplied together, that's the mountain. You can break it down into 2 individual terms that are added together, and they each get their own log, okay? So what we're doing is we're taking a product and we're turning it into a sum. So really what logs do, proverbially, they make molehills out of mountains. What they do is they bring everything down one rung on the operational ladder. Here's the operational ladder, right? We know what it is. We have addition and subtraction on the lower rung. Then we have multiplication and division on the next rung. And up here we have, I'll just write it exponentiation. Okay. So what we did here is we took multiplication and we brought it down to addition. Now, why is that a lot better? Well, products can be really, really large, can't they? But if you can factor them into smaller numbers, you can then expand it and turn it into the log of individual factors. And because they're terms now, you can attack terms one at a time. You can conquer that term, and then you can conquer this term and the next term, and then you just combine the results at the end, right? By adding them together. It's like a divide and conquer thing, all right? So let's try it out. Expand. What does that mean? Well, let me do a couple things before we get to it. I know we're short on time and I've already kind of used up some of it. Thank you. Thank you. If you go from left to right, it's called expanding. Okay. But these are identities and they do work from right to left. So if you go from right to left, it's called condensing. So when might you want to use condensing? Well, if you're done working with something, you know, and the logs have served their purpose and there's still logs in it, you can condense it back down into like a smaller nucleus, right? Which a smaller package would be better for like traveling, right? Or storing on a shelf. When you're not using it, condensing is good. But when you want to use it, expanding is better. To make another analogy besides the mountain, it's like the blankets, right? And the space bags, right? It's winter, you're using them. And then they sell these things where you can put them in there and you can vacuum out all the air. And you can get like 52 blankets in like something the size of a pancake, right? When you suck the air out and then you put it under the bed or something for the season, right? That's condensed. And then it gets cold again and you take them out, right? That's expanding. And in Texas, you're doing that like every 2 days all year long, right? Because the weather. Yeah, all year in the summer, like we got a cold front coming in, right? Oh, it dropped to 95. Better get the blankets out. In summer, when we get a cool front or a cold front, that's what it is. The temperatures drop from like 103 to like 90, 98. And you're like, oh, better bring my jacket. Get the space blankets out, honey. Now, why does this work, right? we know the how. This is the how. This is what we're going to do. But we like to answer the question why, don't we? Question mark. Okay. Well, because a log is an exponent, right? A log is an exponent. The rules of logs are really just the log of exponents on the other side of the coin, flipped on their head. That's all they are. We already know this, right? When you're multiplying and the bases are the same, x to the a times x to the b, your bases are the same, and you're multiplying. What do we know to do with the exponents? We add them together. Very good. So we've already been familiar with a product turning into a sum. Yeah. You know that already. A log is an exponent. So the rules of exponents are the rules of logs, turned on their head, right? Upside down. Yeah. Now let's try it out. Expand. Well, it says the natural log of 3 times 5. That's the same as the natural log of 15, right? So if someone had started with the natural log of 15, you're like, whoa, easy there, partner, 15. Slow down. I'm not ready for that huge number, right? You could factor it into 3 times 5.
Or you can also factor it into
15 times 1.
or natural log of 3 plus natural log of 5.
Oh, well, that's not factoring it. That's expanding it. But yes, Brady, we could expand it now. If we write it as the natural log of 3 times 5, we can write this as the natural log of 3 plus the natural log of 5. Now, when you write the natural log, you don't need to put parentheses around the argument. If you put a plus sign after the 3, we will assume that we're outside the argument and that the thing that follows is another term, right? Is it okay to add these? Yeah, your calculator is going to require that, all right? But for us, for common sense notation, if you want the natural log of 5 to be in the argument, then it's incumbent upon you to put parentheses around it, right? But without them, we'll just assume that it's 2 terms, right? Now that's good. That's divide and conquer. Now, I don't know what the natural log of 3 is. I don't know what the natural log of 5 is because they're not powers of e. I know that the natural log of 3 is going to be 1 point something, and the natural log of 5 is going to be 1 point something, right? Yeah, and the natural log of 15, because e is about 3, 3 squared is 9, it's too small, 3 cubed is 27, too big, it's going to be 2 point something. Well, 1 point something plus 1 point something should be 2 point something, right? Yeah. Now you could also do this. What if you have the 15, you're like, whoa, hey, yeah, I'm going to use the properties of logs to turn this mountain into another mountain. And your friend's like, what? You're like, just bear with me, bro. I can write that as 15 times 1, right? I got this idea from Brady. Now let's expand it. This is the natural log of 15 plus the natural log of 1. ¿Verdad? See? Yeah. Now, what is the natural log of 1? You should have this memorized. Yeah, it's 0. What's log of 1 of any base? 0. It's the x-intercept, right? What's the natural log of 15 plus 0? The natural log of 15. Very good. I see what I turn a mountain into a mountain. Presto magic. Poof. Right?
So you did a complicated persuasion.
You can't do that when you're sleeping, everybody. You can't do this when you're sleeping.
You just picked it up and put it back down.
Yeah, I picked it up and put it back down.
We just did a 5-step equation.
I picked it up and put a coaster underneath it. And then before I set it all the way down, I took the coaster back out. Yeah. Now, I don't think y'all believe me. I kind of get this sense of distrust floating around in the air. So let's go to the calculator. That's good. A healthy skepticism is okay. Be respectful about it though, right? A healthy skepticism is great. Question everything respectfully. That's how you get an education. Make people work on your behalf, right? Ask why. Do a little research yourself too, right? All right. So let's turn this thing on. Turn the calculator on. Calculator. And let's type it in. Natural log of 15, close parentheses, boom. Yeah, I knew it was 2 point something. Now let's try the other version of it. Natural log of 3, I got a close parentheses, right? Calculator automatically opens it. Plus the natural log of 5, close parentheses, develop good habits. If it's not the same number, we go home for the rest of the year, at least for first period, because it's not worth coming in. If math doesn't work, what are we studying? This is just smoke and mirrors. Ah! See y'all tomorrow. Right?
Not me.
Yeah. Not you? Oh,
Oh,
okay.
yeah, he's gonna get his wisdom.
Oh, that's right. Yeah, yeah.
I won't be wise.
No, you won't be wise anymore. But what's cool is when they take your wisdom teeth out, they insert knowledge pills in their place, which over time grow back into wisdom. Not teeth, though, just
Not teeth.
wisdom fillings.
I hope not teeth.
Yeah.
I don't wanna get them removed.
Right, right. Yeah. It works, doesn't it? At least the calculator thinks so. All right. That's cool. Let's try it. Let's try this again. Natural log of 4xy. Does it work with variables? I sure hope so. Right? How many factors do I have there now in the argument? 3. When I expand it, guess how many terms I'm going to have? 3. Natural log of 4 plus the natural log of x plus the natural log of y. Heck yeah. When you take calculus, this becomes a really important property because, like I said, when you can turn it into terms, it is the divide and conquer. You can focus on each term separately, independently, and then combine the results at the end. It's really, really nice. Okay. So that's called expanding. Now, we could go the other way sometimes, right? Now, if you look at this expression, it's not fully expanded, is it? The first term has 2 factors in the argument. The second term still has 2 factors in the argument. So this thing could be expanded further, but let's say we're done with it and we want to take it with us to Disney World, right? So we want to package it and put it in our suitcase. We want to condense it. How do we condense it? Well, the first thing you notice is that each term has a log of the same base. That's important. Okay. No, but you could use the change of base formula to get there, and that's an honors type question later on. So how do we condense it? We pull one natural log out, and then every argument comes down here in the single argument, and they get what applied together? Multiplied. Aren't I good at hints? I'm good at hints. 4x times 3x times 2, right? And now that they're multiplied together, can we simplify the argument further?
Yes, you can turn the 4x and the 3x into a 12x squared.
Yeah, and then what about this lonesome 2 out here who's now feeling left out? We can get him involved and call it 24, can't we? 4 times 3 times 2 is 24. X times x is x squared. Yeah. And again, when we write it as 24x squared, we're assuming that the x squared is attached to the 24, right? By default, without parentheses, the first term is always associated with the argument, okay? So if you wanted natural log of 24 to be a coefficient of x squared, you would have to put parentheses around that. Now it's a quadratic, right, with a funky coefficient. Whoa, what did I do? Okay, I tried to undo it, but I hit the wrong button. Don't panic, right? Just stay calm like I did. 24x squared. Okay, 24x squared. All right, now let's see if we get the same thing if we would have expanded it all the way. All right, if I continue to expand this, I'll move left to right this time. It's the natural log of 4 plus the natural log of x, right? Plus the natural log of 3 plus the natural log of x
minus the natural log of 2.
minus the natural log of 2.
Plus the natural log of 2.
Oh, yeah, I covered it up. Right, yeah. Now I can combine like terms, can't I? I have one natural log of x plus another one of those. One of those plus one of those makes how many of those? No, it's 2 natural log of x. One of those plus one of those is 2 of those. Those being natural log of x's. And then I have plus the natural log of 4, plus the natural log of 3, plus the natural log of 2. Now, with the 2 in front on the natural log of x, I'm kind of hamstrung a little bit. I can't combine them, but I can still condense these guys. That's the natural log of 4 times 3 times 2. So I get 2 natural log of x plus the natural log of 24. I can't really condense it further because this 2 is now in the way, right? I haven't learned how to handle coefficients in front of the logs, right? So let's come back to that. There's got to be a way. When there's a will, there's an A, right? All right, let's look at property number 2. It's really the same thing, but it brings in the division, right? Multiplication, division, or inverse operations, or really the same thing. Division is multiplying by the inverse. So if I have the natural log of A divided by B, I can expand it and give each factor, one in the top, one in the bottom, their own log. But now it's subtraction. The factor in the denominator gets subtracted. The denominator factor, or factors, there could be more than one, they get subtracted. Easy to remember. The positive term is multiplied in the numerator. The negative term is multiplied in the denominator. Let's try it out. Expand the natural log of 4/3. Oh, I hate fractions. I love logs though. Can I expand this? Yes, we can. The natural log of 4 minus the natural log of 3. Good. And now you're like, hey, 4 is too big for my blood. I can call that the natural log of 2 times 2, right? Now that means it's the natural log of 2 plus the natural log of 2 minus the natural log of 3. Oh, and then new column. What is 1 of natural log of 2 plus another one of those natural log of 2s? 2 natural log of 2s minus the natural log of 3. Ah, yeah, there you go. So see what we're doing? We're taking these gigantic numbers that are not prime, like 4, and we're breaking them down into their prime factors. Boy, you know what? Computers, programs would much rather do smaller calculations and more of them than fewer calculations with bigger numbers. Did you know that? That's a fact. Computers run more efficiently, I should say. Computers don't have a preference, right? They don't have intelligence, right? I think. Computers crash less. They run more smoothly when they do more calculations with smaller numbers than fewer calculations with bigger numbers. So believe it or not, natural log of 4/3 seems like it would be an easy thing to do or preferred, but no, a computer would much rather do this version. So logs, remember, are designed to slow things down. They're the inverse of exponentiation. They go to infinity very, very slowly. They slow things down. That's what they're designed to do, right? Stop and smell the roses, comma, get you some logs. That'd be a good saying from now on, right? Stop and smell the roses, get you some logs. And you'll confuse people because they're like, what do you mean, get me some? You're talking about flowers and now you're talking about wood? I don't know. How is you buying lumber going to help me? You're like, no, you don't even get it, bro. Did you even study in math class? Were you awake? I wonder, stop and smell the roses, get you some logs. They slow things down, right? In today's fast-paced world, we can use more logs, can't we? Yeah. I slowed things down really early at the beginning of class, right? With my disc jockey fairy tale. Let's try this. Let's try it. Natural log of alpha y equals 4 divided by 3, close parentheses. Hey, 0.287. Let's type in this version. 2 natural log of 2 minus the natural log of 3. Hey, I even prefer typing that in because I didn't have to hit alpha y equals enter and use that cumbersome horizontal division bar called the vinculum. Hey! Now, did you know that when I type in the natural log of 4/3, your computer in your, or whatever this emulator of a computer, is actually calculating it using a polynomial with many, many terms. And when I type in 2 natural log of 2 minus natural log of 3, the program is actually using a polynomial with many, many, many terms, okay, to approximate it to whatever extent. Those are called Taylor polynomials. But polynomials are easy to work with. So if you have multiple terms of a polynomial, it's a lot easier to evaluate than logs, all right? So anyway, good to know it's the same, right? Now, I don't know how to condense it further, do I? Because now I have this freaking 2 in the front. We're going to learn something. Yes, Brady. Very good. All right. Let's go ahead and expand this one. How much time do we have, Brady?
9 minutes.
9 minutes. What did you actually say, Brady? I'm sorry.
9-ish minutes.
No, before that, we can actually do what? When I cut you off.
We could just basically combine the number before with the number after it, and be the same.
But I don't know how to deal with this 2. This is a coefficient now. I can't condense it because the 2 is there. But hang on, Brady. We're going to learn how to fly away. And then it just no. But when your log floated away, Brady, to your credit, it stayed nearby. It was there when you needed it. Look at this. Natural log of 7 divided by 6x. How many factors do I have?
3.
3. Very good. 1 in the top, 2 in the bottom. Okay. When I expand it out, how many terms am I going to have?
You're gonna have 2 at first, then you're gonna expand it again to 3.
Oh, okay. I see what you're saying. Let's do that. I have the natural log of 7 minus the natural log of 6x, right?
Yes, then you expand it again to the natural log of 7 minus the natural log of 6.
There you go. Okay. Whoa, yeah. So notice when I use the division rule, natural log of the top minus the natural log of the bottom, it's not fully expanded, is it? I can expand the bottom still some more. Now, when we do that, we have to be cuidado, cuidado. We have to be careful. Caution, said Dora. Because it's multiplication there, isn't it? So it's got to be a plus. But if I do it like that, am I winning like Charlie Sheen? Is he still winning? Is this correct? No. No. Because I'm missing the all-important parentheses. Yes. This is why it's, oh, wow. I'm working in the denominator. Now, if I distribute it, I get the natural log of 7 minus the natural log of 6 minus the natural log of x. Más mejor que bueno. So here's what I would encourage you to do. Skip this step in the future and just tell yourself, if there's 3 factors, there are going to be 3 terms. If it's a factor in the numerator, it's added. And if it's a factor in the denominator, it's whatted? It's minused, subtracted. Yeah. Okay. These get subtracted. And any factor in the top gets added. Let's try this real quick. Let's try log of x, x, y, z over p, q, 7. PQ7, I meant 7 PQ, right? Yeah, we typically write numbers in the front. Go ahead and expand that. Expanded, expanded. Try to do it in one fell swoop. Oh, I wrote LOG. That's base 10. Will it work with LOG? Yeah, it will. I did that on purpose. These work with any base that's legal, right? Greater than 1 or between 0 and 1. Don't get a big head about it or anything, but y'all are my favorite first period class this year. Yeah, right. Brady, don't tarnish the gem that I just threw out.
Yeah.
How many factors do we have in the argument? 6, 3 in the top, 3 in the bottom. So I'm gonna have 3 positive terms and 3 negative terms. And they each get their own log. Everybody's getting a log, right? It's like we're at the Oprah show. Everybody's getting a log. So it's log of x plus log of y plus log of z minus log of 7 minus log of p minus log of q, right? And that's expanded. So if you could read it slightly differently, right? You can read it as log of x plus log e plus log of z minus log of 7, right? Log e. Or that'd be log g. Log e would have 2 g's, right? Yeah. Log g, yeah. Anyway, that's expanded. So if we can do this in one fell swoop, we'd be good, right? One fell swoop means in one step. So we don't have to worry about that intermediate step that Brady was so prescient to notice. Because if you do that, you're having a whole nother line of writing, first of all. So it's more time. But it also is possibility of making careless mistakes because you might forget the parentheses, right? So just train yourself. If it's in the top, it's a plus. If it's at the bottom, it's a minus. Okay. Now, real quickly, where does this come from? Not France, but math. I don't know who do. Italy, maybe. Yeah. Italian mathematician. Giano Cardano. Real guy. Look him up. Cardano. Giovanni. I don't know if that's his first name. It started with a G. Cardano. He was a good guy. All right. It comes from the rules of exponents. When you're dividing and the bases are the same, what do you do with the exponents? You subtract, right? When you're dividing and the bases are the same, yeah, I'm just going back to where this comes from. You subtract, right? So here we have a division turning into a subtraction. So again, this rule that we just practiced is nothing more than the rule of the exponent turned on its head. And then real quickly, the last one, we'll do a little bit more practice tomorrow. The last one, let's look at the exponential rule first. When you raise a power to a power, that's called exponentiation, right? What do we do with those? We multiply them, right? So exponentiation turns into multiplication. It comes down one rung on the operational ladder. Same thing with logs. This is my favorite one, okay? Like if you're ever on a game show and one of the categories is Mr. Corpy, and it says, what is Mr. Corpy's favorite log property? 1, 2, or 3. You'd be like, what is 3, Alex? Right? Whatever. Poor Alex. I love that guy. The natural log of A to the bth power, to the power of B. I can bring that exponent out front and turn it into a scalar multiple. This is the expanding. But wait, there's more. I can go from right to left. I can bring something that's a factor in front of a log back up as an exponent on the argument. Hey, yeah, let's return to the scene of the crime. Up here, I could bring the 2 up and call it the natural log of x squared plus the natural log of 24. And now I can condense those and call that the natural log of 24x squared. And that is what we got over here. Ah, yes. And over here, we could bring this up and call it the natural log of 2 squared, which is the natural log of 4 minus, and then we can condense further and call it the natural log of 4/3. Yeah.
What are we gonna eat?
Yeah,
I don't know.
we're gonna start.
We eat the spaghetti at the Cardano's house. Yeah. All right. Y'all have a fantastic rest of your day. Now beat it.